Hello, everyone. I think we can start today's session. So thank you for joining me, especially like if you're in US time zone, probably that's quite early for you. So thank you very much. And for everyone else also for joining me. So today we'll talk about the code analysis plus. So actually it will be a talk on code analysis in modern C++ and how it reflects the C++ challenges and changes coming over these years and how it interacts with the new and modern language. So before we start, just a few words about myself. So my name is Anastasia Kazakova, for those who don't know me. So I spent actually 8 years in embedded and networking areas as a C++ and C developer. And I would say that the most amazing for these years was my work when we were launching the first LTE and 4G networks in Russia. That was there were amazing tasks and lots of interesting and unique challenges. So mostly these days, I'm not coding for 24 hours. I'm working as a product marketing manager for JetBrains for our C++ tools. But I would say that these days I know the language even better compared to what it was when I was developing in the actual language. And so I actually started also my user group in St. Petersburg. So if you're ever somewhere around, just join us. For now, it's on hold because of the pandemic, actually, and I'm probably not that ready to start it online. So, but I'm also driving several conferences as a PC member, so including my active participation in C++ Russia organization, the conference which we held in Russia. And because of all these factors, actually, my talk is not a pure language talk, but it's definitely also not about the marketing. But it will be about the tools and the language and how they collaborate. But before we start about talking on code analysis, let's start with the more general and maybe obvious to some, but still topic about the software quality. So let's try to explain what it is actually and how the code analysis relates to it. So let's define the quality. So some people say that the software quality is just when the software works reliably and efficiently, so that it doesn't have bugs. So this is good. So it's good when the software doesn't have bugs, but it always has some. It just depends on how critical they are. So, but it's also important to see how readable the software is, how maintainable it is, how extendable it is, so that we can actually work and extend these projects. And this brings the people quite often to this kind of a trade-off between the quality and the cost of development. And some people say that, I could develop faster if I don't care that much about some quality aspects. But I don't think it's right. And you probably have heard or read the Martin Fowler, who is an adept of the software quality and lots of tools in this direction. And he has a very nice article which he posted in, 2019 about the high quality software and if it worth the cost. And in this article, he talks about the internal and external quality. And this is very important. External quality is what the users see, like the features, bugs, regressions, performance, UI and UX, whatever. And internal quality is what the users can't see, but they actually can feel it, because that's the architecture, that's how you do things. And the users often request the external features and don't want to pay for the internal stuff. But because of that, actually, some developers teams, they are often afraid of stopping this loop of bringing some external features, and they are afraid of quality releases. But in this article, Martin actually discusses that the internal quality, it guarantees the external quality, because when you have the system which is easily extendable, you can bring the new stuff quicker and better, and you can add new features quicker. So probably if you just do a coding program for, ICPC programming challenge, you probably don't need to care that much about the internal quality. So you'll throw away the whole code in maybe hour after the challenge is over. And so if you just done the task, if you submitted it and it brought you some points, you're done. So you don't need it. But if you're in the actual production development, where I come into this plot is taken from this Martin Fowler's article. And it shows how the evolvement during the timeline of the software, the internal quality and the external quality actually intersect. So when you start, you probably need some bigger effort to start with the better internal quality, and you're a little bit slowed down because of that. But then there is some point of intersection where the software with the better internal quality actually brings you more, and it provides more value, and you can build better system on top of it. So the internal quality is actually very important in that sense. Okay, so we got this kind of general topic about the software quality defined. Let's now talk about more on C++ specific. So let's think about the internal quality, and let's think about what the C++ developers are quite often frustrated with. So I took these reasons from the C++ developer survey run by C++ Foundation in April. So they already published the results. You can find them on ISO CPP blog. And the top frustration points are actually about the memory safety, about these typical issues like tangling pointers, about security issues. So the C++ developers are actually caring about them, and they are frustrated about many things in the language and about these things which brought them to the lower quality and more problems in the software. Okay, so we know about these points of frustration. There are actually other points of frustration in the survey, and there are quite many related to the project models, to the whole setup of the process. But on top, there are still these language points, and especially these concurrency and security and memory issues with the most frustration they bring to the C++ developers these days. And also, if you talk about the frustration, there are the kind of these style wars. You probably remember this large thread, which I call the range on ranges. So when the Eric Nibler posted a nice blog post on the ranges v3 library, and there was this example with Pythagorean triples in it, the huge Twitter thread started by Aras from Unity, who actually noticed that the code is less readable with all these new additions to the language, and so it's kind of hard to read how to maintain this code. And also there is this, like in this thread, it was mentioned several times that in C++ we actually have like more than one way of doing the things right. And so it's probably not good sometimes. And this is the typical example. On the left, you can see, so this code on the left, if you remove all these sugar, all these templates, it actually just returns the 42. That's all it does. So, and I could just write a function which, like the main function, which will just, the only thing it will be doing is just return 42. But this is the same code, so like it does the same. So the actual semantic of this code is like just the same. But it looks kind of more complicated. It looks like maybe I'm doing some more stuff out there, but I don't. And if you read this nice book by Google software engineers, there is a Hiram's law mentioned there. It's about the APIs, but I think it's applicable to the language as well. So about the API, it states that with a sufficient number of uses of an API, it doesn't matter what you promise in the contract. So all observable behaviors, all observable paths will be taken by the developers. And I think that's true for the language. So if you have like 10 ways of doing the thing, 10 ways will be used anyway. So especially taken that C++ is that widespread among several areas, and it's top language for things like game dev or embedded or like financial, HFT. So they will be used. So, and the style wars, they're actually coming out of this fact somehow. So I kind of understand in that sense the general direction taken by Herb Sider and others who are now trying to make C++ safer and simpler and take this as a major goal of all the changes they are like pushing to the standard. Also, there is this aspect of the certification process, like we have, especially in embedded. So, like since I came from the embedded area, I was kind of close to this, and I know how it more or less how it works and how you push to pass the certification process. So we have this MISRA, we have AUTOSAR standards, and the certification is a must-have if you're, for example, doing a self-driving car. So you can't put it to the public road without passing lots of tests and lots of certification. And so I actually, there is a funny story which I could tell you here. So my first ever C++ parser, so I did it while I was working in the outsourcing company, and we got a task from the military people, and they had some software, and they needed to pass the standardization process. And for these standardization guidelines, they actually had to have a comment on each reasonable line of the code, and the code was in C++. So no one was planning to like read through these comments or like check them in detail. So what we did, we actually just parsed the C++ code, generated the AST, and then just generated the comments for every reasonable line of the code. So that was just the part of the task, just to allow this company to pass their standardization process. So yeah, there is this kind of the metrics and this certification in place. Okay, so what else is there for the frustration points? So definitely undefined behavior. So whatever you mentioned about the C++, everyone already will remind you that, yeah, we have the undefined behavior. And so this is kind of the things we are dealing with. And it's, I can't say that it's that bad, but sometimes it frustrates the people because all these issues with the data races, with the memory access, with all this signed integer overflow, the biggest issue probably about it that there is this no diagnostic required philosophy built in. And yeah, it's not just the name of the podcast we took together with Phil Nash. No diagnostic required philosophy actually indicates that some code is ill-formed according to the language rules, but the compiler need not issue any diagnostic or error message on that. So we have to keep in mind that there might be an undefined behavior, and we have to care about the situations, and we somehow have to detect that these issues are possible. So yeah, and that's an important task to find the tools or find the approach how to detect it, especially in the situations when compiler don't promise us any contract on that. So yeah, compilers are not required to diagnose undefined behavior. So yeah, why code analysis then? Why we are talking about the code analysis today, why it's important. So first of all, obviously, like the code analysis is always taken into consideration when we talk about the software quality. So if we want our software to have better quality, we try to run some software analysis, some code analysis on top of it. Also, code analysis might actually help with lowering the developer's frustration, and it might help with the avoiding the undefined behavior because the compilers are not helping a lot here. So, but the code analysis, they are not following this contract. They can show you what are the issues possible in your code. So now let's actually move to the language and to the tooling. And by the way, if you have any question or command coming during my talk, so you can just drop it to the question pane. So I will be following the question pane on, here on my computer. So I will try to address the questions just when they rise. So that's fine if you just drop any words or any messages to the question pane. So just don't be shy, voice it. Okay. Before we talk about the tools, let's first talk about the language, because the language is powerful enough. It actually helps us. And it now, with all the current trends in the language, when the language strives to be simpler and more readable and easier for those who actually maintain the code in C++, let's see what are the recent examples of how the language helps, because it is actually helping us a lot, even before we move to any tools here. So the first thing I would like to mention here is, of course, the lifetime safety proposal. So I'm not going to dive deeper into the proposal itself, so you can find it and read through if you haven't heard about it. But the idea is that the idea of the proposal is to diagnose common cases of dangling, like use after free or use after move at compile time by using some local analysis. So it introduces the concept of the owners, those who own the object, and shared owners and pointers, so those who just refers to the object. And there's also this language of annotations. So you can put annotations to some libraries like standard library, for example, or eigen library, or whatever you're using, or your own code, and then rely on some like compiler or some external tooling, which will then give you some like warnings or some analysis checks, trying to prevent these kind of use after free or use after move cases. So the proposal actually builds these rules and defines how this language of the annotations could be defined. So, and it's a very interesting proposal, I would say, and it's partially implemented. There is like a Clank branch, I guess, where the lifetime safety proposal is implemented. It's still not in the trunk, so it's some kind of separate branch. I guess you can find it on Godbolt on Compiler Explorer. So if you want to play with it, and also there is some implementation inside the Microsoft Visual Studio. Another thing here is contracts, of course. So yeah, we don't have them for C++20. We might get them for C++23. So the link to the proposal I have here is this link to the very new proposal, which defines, like, somehow redefines the contracts, because the previous iteration with the contracts end up in the overall understanding that we don't know what we want to build and what we're actually building. So if you have checked the previous proposals on contracts, do check this one about the new iteration of defining the contracts. So just that everyone are on the same wave before we start building the new language features. So the value that it brings, it actually brings some semantic to the language and to the way we provide the parameters, so that we could, how we build the code and the conditions which are there in the code, so that you can catch actually some programming errors in your code with the help of these contracts. So there's these pre-post conditions, like the preconditions, like a predicate, which is supposed to hold upon an entry into the function, and the post, the predicate, which is supposed to hold upon an exit from the function, and also assertions. So the predicates, which is supposed to hold at the point of the computation. So you can build some analysis on top of these contracts. So you can check for these contracts, and you can check them at compile time, or you can build some analyzers which will be checking these things for you while you're like writing the code. So anyway, the language helps here. So it provides you a way to explain some semantic behind the code to the automatic tooling, because without that, the automatic tooling can just only guess and maybe provide too many false positives for you. And another one, yeah, so I mentioned parameters. So actually parameter passing is just the very same direction they are taking. So they are bringing this semantic of the parameters to the actual language, so that you can mark the parameters like that they in or in out or move or whatever, and then you can build some analysis. For example, if you have an in out parameter, so you're supposed to read it and then write to it, so you can check that you just read from it actually, and only after that you write to it, and that you actually write to this parameter as an output parameter for your function. So you can do some kind of the checks based on this additional semantics brought to you by the language. So yeah, if you take a look at 3 recent things which we're kind of discussing right now for the future iteration of the language evolution, lifetime safety, contracts, and parameter passing. These just the 3 examples. There are more. There are like small things and big things. I just selected these big things to show you how it could enhance the analysis you do on the code. But okay, so I'm talking about language here. The language, and most of these proposals are considering that they will be compiler checks, which I think not always good. There's good points and the bad points about that. So if you take and compare the language together with the compiler checks and compare it against the standalone analyzer, there are a few points to mention here. So first of all, like, yeah, the compiler is the core tool. So, and everyone has it, and everyone in the team are they are just using the same version. While for the standalone analyzers, there could be versions, there could be like different tooling, different tools the team is actually using. So we are probably not in the same way. So with the compiler, it's much easier. But the compiler job is actually to compile your code. So it's not about providing you the full featured analysis sometimes, because its main job is to take some period of time and to compile the code in this period of time, and not spending time on something which is probably not that required. But the good thing is that so the compiler is actually standard to everyone. So if you have the compiler and you have the check there and you just turn it on for everyone in the team, everyone will be having this check. While with the standalone analyzer, so the things might differ from one team member to another. You can still share the analysis profiler with everyone in the team, but you somehow have to force everyone to use it. So it actually depends on the tool, and it actually depends on the person, on the developer using it. And also, like, with the speed of delivery, the checks to the compiler and the speed of adopting these new checks in the compiler is much slower than with the standalone tools. That is natural, because if you're with some compiler, with some version, to move to another version of the compiler might be not that easy, because of the whole code base you maintain, because of the whole libraries you use. Maybe you have some libraries in binaries, which is kind of bad probably, but we do that from time to time. Just a recent example, like the GCC released the GCC 11 version, and they had the whole page of the porting tips. If you've seen that, you might be surprised, but still they are there. So there's like a whole page of the porting tips if you update your compiler to the GCC 11 version. So yeah, this is about the compiler usage against the analyzer usage for the purpose of the code analysis. Now let's talk about the tooling. So, and let's move to these standalone analyzers in particular, and what are they? So when we talk about the software quality, if we try to place the static analysis in the list of other tools which helps with the software qualities, there actually will be a long list. There will be refactorings, there will be peer programming, static analysis itself, unit testing, dynamic analysis, which analyzes the code during the runtime, code review practices, and some other testing like regression or performance testing. And the interesting thing is that I usually tend to divide these tools to the pre-compilation phase and the post-compilation phase, or like exactly the compilation phase. And the static analysis is unique because it can happen on like all three. It can happen on the pre-compilation phase, it can happen during the compilation phase, and it can happen after the compilation phase, on this post-compilation phase. And that's mostly when you run it on the CI, for example, or do that during the code reviews, or you like use the code analysis on pull requests, whatever. So this is unique. Like the static analysis is just not the tool you're using on some particular phase of the code development. It's the tool you can use on all three. And actually there is sense on using it on different stages on the software development. So there are specific tools which helps you bring the code analysis to the, for example, CI stage. Like there are Sonar tools, like Sonar Cube, when you can run the static analysis on the CI. And there are tools which helps you with the code reviews and with static analysis on code reviews. There are tools which help with the pull requests. Again, there's like Sonar tools, and we also implemented some tools which are focused on code analysis on these stages. And actually, these stagers, they are fine for code analysis. So there are just different set of checks, different set of analysis checks you do on different stages. For example, if you have something like, everyone understands that if you find the bug, like the problem early in the code, it's cheaper to fix it. So probably running the static analysis on the pre-compilation stage brings some big value to you because you can check the things early. But if you run it on CI, you can run some target platform specific checks or some long and greedy checks, which takes the resources. And so you can only run it, for example, on some other machine on CI or so. And it gives you actually the whole picture in dynamic for the whole project, like how the whole team is doing, in terms of code analysis. Okay, so a little bit more of the statistics. So I mentioned the C++ Foundation survey, but we also run an external extended survey for C++ community and the other attacks here in JetBrains. So it's called the Developer Ecosystem. We do it yearly since 2017. So we have some huge experience with it, and we collect the data from the whole world, like the survey, like weight the data. So there is a whole research team behind our developer ecosystem survey we run every year. And we already have results for 2021. They are not yet public. They are still under processing. We will be publishing them somewhere in June. And the raw data will be available to everyone by the end of summer, I guess, or something like that. So, but I just extracted some numbers from it already, just to show you and to compare the data from last year and for this year. So we actually asked which of the following tools do you or your team use for guideline enforcement or other code qualities and analysis. And that's not all the options we have in the possible answers. I cut those who are under 7%. So they're like Coverity, they're CPP Lean, they're PVS Studio, and some others. I cut them because just they were not fit into the plot, but they are there. So there are just people who are using them. But I wanted just to show you the trend here, so that the those who are selecting none, that's kind of big group. They are probably doing some analysis on CI. We probably have to check this hypothesis later. And also there is a very big group, which is growing every year, when they say that they use something which is built into their IDE. And that makes kind of us as a tool vendors responsible for a code quality, because if we build the tool, you will be using it, and if we don't, you probably will not be using it. So yeah, I feel the responsibility personally. But anyway, yeah, so you can see the Clang family in top. We added the Clang format to the options this year, even though it's not a code analysis tool, but it's a very popular tool for like bringing this style to your code. And there were quite many people who were selecting this option this year. Okay. Let's start with some obvious thing and quickly run into more interesting stuff. So as I said, so you can start the code analysis on with just the compiler checks, and that's fine. So the compilers nowadays, they have lots of interesting checks, lots of valuable checks. There are just a few examples I have here. So if you turn them on, you can find some interesting cases catch by them. So these flags, I guess, work at least for GCC and Clang. So they are kind of common for both compilers. They might have some different naming. That's mostly the GCC naming, but I guess they're just the same. So sign compare, the comparison between signed and unsigned values could produce an incorrect result when the signed value is converted to unsigned. Like size of pointer, mem access, a very interesting check which catches the suspicious size of calculations. Misleading indentation, a very typical error where you're missing some braces because you probably was thinking that, they're kind of redundant braces if I have just one line under if, but then another function jumped in and you just forgot to put the braces. It actually happens. So yeah, the kind of the checks which helps you with this misleading indentation and says that, hey, you probably have missed some braces there, or just the indentation is wrong. You probably need at least to check this out. So if you used to have this minus v all, minus v extra, or even minus v error checks on your compiler, and how we usually do that, we usually have the several profilers. So we have the set of options we like run in some kind of a debug development mode, and then we turn everything off and just build for the production for the release profile. So that's fine. So the compilers are capable of many things here. But again, let's reiterate on that. So when we have checks in the compiler, so we only rely on those which is available in our today's compiler, and the compiler we're using these days. But what if we want more checks, or what if we want some custom checks which are more typical to our team or our company? Or what if we want the checks from the other compiler? For example, a very typical case when the people would like to see the Clank checks in Visual Studio, and so they do compile with the Microsoft compiler, with the MSVC, but they run the Clank tidy and the Clank power tools just to get the checks from the Clank compiler on their code base. And actually, the problem here is that the set of checks might be not common across compilers. So, and yeah, as I said, I was trying to look for the checks for the examples, which are common at least for GCC and Clang, but they would be completely different for Microsoft compilers. So you often can't find how to do the same check in all the compilers you're probably using. And the next point, if you talk about these compilation checks and the standalone analyzers, the big benefit of the compiler is that when you analyze with just a pure compiler run, you actually analyzing with the same set of flags with which you will be building your code base. And this static analysis tool, it has to actually somehow extract these compilation flags out of your build system or your project model, and then use them for the proper compilation, because you probably want to analyze with the same set of compiler flags you're using for just the actual compilation. And you know what is bringing this us to? It actually brings us to the question of the project models. A very interesting statistic. So I know we had a nice keynote by Bill Hoffman yesterday, and thank you, Bill, for creating the CMake and for pushing it forward together with the kitware. And I can see how the CMake grows for many years now. So we run the developer ecosystem survey since 2017. And they were the first years when the CMake was actually below the MS built and make files. And now it's on top. That's the first and the quickest growing project model due to all our surveys. So here I collected the results from the DEF System Research 2020 and 2021, and also added the comparison to C++ Foundation results. So yeah, we have big numbers for project models. There are others here, like the Boost, Build, Scans, Mason, and Basil, but they're under 5%, so they're not on this plot. And yeah, we added some only in 2020, like Ninja and Gradle, only in 2021. So I have only data for 2021. But the top three is kind of clear. So it's CMake, Amazbuild, and Makefiles. And CMake is growing faster and faster. That probably will resolve this question of the like the lack of the standard build system in the C++ world. Okay, so the compiler servers, they're clear, but what else do we have? We actually have a very powerful tool set here. So first of all, we talked already about the lifetime safety. So, and the lifetime safety is the proposal actually proposes to build them into the language so that we can, with the help of the compiler, catch the situations like that, that the object backing the pointer will be destroyed at the end of the full expression here. So this example actually, so yeah, the lifetime, as I said, it's implemented in Clang branch. It's implemented for ID live squiggle diagnostics in Microsoft Visual Studio, and we're now building it into C-line analyzer, which is bundled into C-line and Clang-based analyzer we're doing there. So yeah, and these free analyzers, they some of them can already do that, and some of them will be doing that. So we'll be catching these things for you. So when we have the proposal into the language, probably other compilers will be also able to catch these kind of things in the language. And it's not about just analyzing the code. It's yeah, some examples of the iterators here, like the dangling operator. So also like catched by the as it stated in the design of this proposal. And there are also these annotations like GSL owner and GSL pointer and shared owner. So you can actually annotate your code. And with the help of this annotation, the analyzer, either the built-in into your compiler or something that you have like separate, like in C-line, our code analyzer built into the ID will be able to catch these kind of things like the address of the local variable escaping the function. And this message actually is deduced from these annotations stated here. Okay, lifetime safety is good, but how we did that in C-line, how we started doing that, actually it's the part of the biggest story for us. And it's a very interesting part of analysis you can build into the and run on your project is the data flow analysis. The data flow analysis is the one that analyzes how the data flows through your code and make some assumptions based on that. Let me show you just a few examples. So here's the code, and the data flow analysis actually can say here that the condition is always true when reached, which is true because on the previous if else clause, I either assign the color red or the color yellow is assigned. So yeah, the second if clause, the second part of this statement is actually always true if reached. So the compilers, they usually can't do that because they are not tracking how the data flows through the code. They actually don't need it because it will take too long to compile. So that's not the thing for the compilers, that's the thing for the external analyzers. So we started doing that in C-line, and we realized that with this thing, we can actually do the dangling pointer analysis on top of this data flow analysis. So we can catch, like in this situation, that here's the dangling pointer in this piece of code. But there's actually more interesting stuff. So how the regular code analysis quite often works, and many tools are working just in the context of the function bodies. But what you can do, you can actually do the analysis of the context of the translation unit, which is much, much more. And you can catch the dangling pointer in the situations like that. So when you have the deletion of the pointer in some other function, so it doesn't happen in this function inside this function body, but it has it's happening in some other function. So, and if you do the analysis inside the translation unit, in some cases, not in all, you can catch the situation and you can find that, yeah, so here's the dangling pointer. So to analyze the whole translation unit, we actually are using some, let me share some details how we do this interprocedural data flow analysis. So it's actually quite complex. So, and the complexity is nonlinear. So we choose the translation unit just as a single unit for the performance purposes. So how it works, so there are private entities. The private entities means that all usages of these function and fields are guaranteed to be located inside the translation unit. These are like private members and functions, private member functions and fields. These are static global functions. These are functions and fields of classes in the anonymous namespaces. And also there are unsafe entities, which are just practically all the rest, like virtual functions or functions with pre-declarations in headers, or externally defined functions, or functions in classes with friends, as friends are not that like friendly to the code analysis, and they can be declared in other translation unit and access the private members. And here I have some examples. So I have two translation units, and I have my class C with several functions, and I have a call like C. I have the C full function definition, and it checks if P is equal to 2. And if I analyze the code only inside this translation unit, I can say, yeah, this condition is always true because we always call the full function with the parameter value 2. But if we take the translation unit, the second translation unit, there will be a call for this function with the value 3. So if there is a call outside of this translation unit, I can't rely on this kind of analysis and say that the condition is always true. So this is about how we build this analysis. So if we analyze the translation unit and we only work with the private entities which are safe for this analysis, then we can make some assumptions on the code and say that, like, yeah, there's, for example, a dangling pointer here. And if we see some unsafe entities, then the analysis just stops because it can't do something about it, or it works only in the local mode inside the function bodies. So what actually this analysis is capable of? First of all, it enriches the local analysis. So everything you can do inside the function body, you can actually analyze this inside the translation unit. So it could be the constant conditions. So like, for example, the conditions that are always true or false. It could be the dat code. It could be the like very typical null referencing, or the dangling pointer, which I showed previously. It could be the endless loop and infinite recursions, which sometimes they could be the part of the design, but sometimes they are not. And it's like nice when the analyzer could point you to this. And of course, the escape analysis, which actually shows you these cases when the variable escapes the local scope. But also, since we're taking the bigger entity to analyze the translation unit, you can actually build some interesting new analysis which are not possible in the local scope. And so, yeah, this is the example of null dereferencing in the global scope when you have the actual assignment of the null pointer in other function. So what are these analyses which you can build additionally, which are only possible in this kind of global, so in the scope of the translation unit analysis? So we actually started with 3, but I believe there could be done more. So the first is the constant function result, when the value appears to be always the same constant, the constant function parameters. And the most interesting is the unreachable calls of functions. Like here, this example, if you have some call which is like always full, then the full function is marked as an unreachable code. And it's practical and only possible in the scope of the translation unit to get this kind of analysis and to understand what is actually going on there. So, okay, but can we do actually more? So as I said, we took the translation unit for the scope of the analysis just because of the performance purpose. But yeah, and if you're interested kind of in trying these things, so this analysis is now built in CLine ID, which is the JetBrains ID for C++. So we have the local data flow analysis, I guess, in some very first version of the tool. And we also have completely rewritten it on top of Clang. We're not big porting it to Clang, so you can try this in the trunk version of Clang. So it's only possible to try it inside CLine since the last year, last like 2020.1 version. And this April, we actually released the global data flow analysis, which happens in the context of the translation unit. And we are building the lifetime analysis on top of this global DFA for the next release. So, but there is a very interesting direction actually to get more. So we're not doing that right now, but we are like trying to research this. And if you're interested, you can check some documentation on the Clank site and some attempts to do the cross-translation unit analysis. So the analysis which happens on like between the translation units. So there is this thing in Clank which you can use, and actually this cross-translation unit analysis, it uses two different approaches. One is to like construct precompiled header dumps for all translation units in your project, like map the names, and this is called the cross-translation unit analysis index, which you build, and then you use the compilation database to get the compilation flags and run the analysis. And the second approach is when you just build in required AST parts for external translation units by request. So when you actually need them during the analysis, so you just use the compiler invocation and also use the compilation database to get the compilation flags. And if you ask me if there is any practical usage of this, yes. So I guess several years ago at LVM meeting, Ericsson was some people from Ericsson were presenting this tool called Code Checker. It's available on GitHub, so you can find it by the link, and it does exactly that. So it runs some analysis in the cross-translation unit mode. So it exactly has these two stages, like two run-throughs, like one is the collecting information pass and then the analyzing pass, and they exactly doing these two approaches. So they have both approaches implemented, like one is this load from PCH and one is parse on demand. And you probably already understand the major difference here, like with the load from PCH, when you build the precompiled headers for all the translation units in advance, it could take the significant disk space, and the preparation phase is quite long. With the parse on demand, the usage of the disk space is lower, much lower, and the first preparation stage takes less time, but then it could take some CPU during the actual analysis because it will be parsing some AST on demand when the actual analyzer build them. But anyway, they have some checks which are already running in this cross-translation unit mode. I'm not sure how accurate they are. That I just think that they did it for proving the idea works, but they are not probably actively contributing to it. If you want, you may take this and make a like full-fledged analyzer working in the cross-translation unit mode out of it, I guess. And so yeah, the capabilities are there, so you can try that out. So we talk about the lifetime safety, the data flow analysis. Now let's talk about the core guidelines. So when you talk about the code analysis, you can't escape the question of the core guidelines. So the core guidelines were introduced by Bjarne at CppCon in 2015, and they are great, and but they are great not on their own. So as the creators of these guidelines noted several times, and as we probably all understand, that the guidelines without the tooling support is nothing. So you can't do anything with the guidelines if you don't have the tools which enforce these guidelines on you, because all the developers, they're just, not really lazy, but we just take our time, our precious time, and we don't want to, extra hassle from all these analyzers. But if we have to use them, and if we have the tool which will be like pushing these guidelines on us, we will be probably following them, and we can set some company or project-wide rules to use these analyzers. So, but with every guidelines, there is always a question which I ask myself, like how applicable these guidelines are, and how possible it is to encode these rules into the tooling. And together with the ReSharper C++ team, we actually analyzed these C++ core guidelines quite recently, and we're trying to understand mostly for ourselves, for our team internally, what is the toolability aspect of the core guidelines. And I want to share some findings from our discussions here. So we divided the guidelines rules actually into several categories. So those that are not toolable from our perspective, so those that we can do in the tool, but we don't see much sense, and I will explain it a little bit later. Those we think we can do and it's definitely worth doing, or those which we've done already, and those which requires the GSL library, but it's also worth doing, but it just requires this annotation library to be used. Let's start with the with the positive side, those guidelines which are quite toolable. And the authors of the guidelines, I think they made a great job of introducing this enforcement section into the guideline. If you ever checked how the guidelines are structured, so you take the group of rules, you read the rule, you read the reasoning behind it, you read the example, and then you check some discussions, and in the end there are like several examples of the enforcements, how you can enforce the rule on your code. And so, for example, here, this F16 rule, like for in parameters, pass cheaply copied types by value and others by reference to const. So, and the enforcements, they are actually trying to define this cheap to copy thing. So it definitely depends on the machine architecture, but seems that like 2 or 3 words are usually best passed by value and the others are best to pass by reference to const. So, and these enforcements, which you can find under this guideline rule, they are really very easily convertible to code checks. So I even like restructured the wording here to show you how I can actually encode them to the real code analysis checks. So for example, if the parameter being passed by value has a size greater than 2 simplified by size of void pointer, then suggest reference to const, and so on. So you can just encode these enforcements and get the checks done, and run these checks on your code base and get the results, get some warnings. And you can catch many things here. And another example here, which is also toolable, is kind of a classical dangling pointer rule analysis. So, and I've showed you several times before already how you can catch the dangling pointers. So yeah, some rules in the guidelines are easily toolable, and you can quite often see that from their description. So those that are actually toolable, quite often that means that you will see a very nice enforcement section for these rules. But also there are guidelines which are not really easily toolable, or there are like some questions behind this toolability. So, and the question would be like, should we always rely on tooling with such guidelines and just let the tooling do their job? And there are several rules here, which I will be using for examples. A very simple one like F1, F2, and F3. They're using the very similar example to explain the rule. Like they have the function which is called read and print, and which actually reads, writes, and handles some errors. So, and the rules are like, yeah, they are stating that package meaningful operations as carefully named functions. The functions should perform a single logical operation and keep functions short and simple. And there are some enforcements written here, which I took from the C++ core guidelines. And I would say that there are questions to these enforcements, mostly because like functions, they are kind of these complex structures with some logic behind them, with some semantics, and just highlighting the issue, that you have more than this number of output parameters, for example, doesn't make any sense to me. So yeah, like everyone who reads through the code, they could probably find out somehow, especially if we have this parameter passing proposal accepted, so we can see how many parameters are passed there, or we can see that the function doesn't fit this rule of one screen, which is like defined somehow as like 60 lines by 140 characters. So we can see it, we have the eyes, we're reading through the code. It probably takes some effort, yeah, so we can share, the analyzer could show us that, yeah, there's these long functions, but what's next? Like highlighting the problem without suggesting the fix doesn't make big sense to me. But the fix is kind of a questionable action here, because the fix actually requires to know the semantic of your code. So it requires to understand how to split your code, for example, into several functions. So, and how to apply, for example, these cyclomatic complexity elimination. So how to extract several functions here. And even if we take the very first enforcement, like detect identical and similar lambdas used in different places, like if they are identical, it's kind of simple, yeah. But what is similar? So let's define similar here. And why I think it's not that easy, because this actually makes us to the point of finding duplicates in the code. It's not that impossible, I would say to you, because we actually have this find searching for duplicates analysis built in our tools in JetBrains, in IntelliJ IDEA for Kotlin and Java and JavaScript, and they are working there. So they can even take into account the anonymizing of the variables, so they can actually extract not just the exactly the same piece of code, but the similar pieces of code. But what about the C++? If you search in the Google search, just type finding duplicates in C++, you'll find this article from the Stack Overflow, which actually suggests you a few tools there. The CC Finder X, I guess it was last updated like 10 years ago or 11 years ago. Dupla is a little bit more modern, and as stated by the author, the analysis of the whole Linux kernel takes just 16 hours. The Quake 2 is much faster, it's just 1 minute. Simeon takes the GDK9 in 5 seconds, and actually it's capable of running the analysis with anonymizing the variables, so it can look for some similar pieces of code, not just exactly the same. But the problem here is in this piece of code. So not exactly in this one. Yeah, this is just return the 42, but that's, the general answer to the question of the universe. The problem is that we have sometimes quite many ways of doing one thing in C++. And if you take all these ways, it might be kind of complicated to understand, to explain to the machine, to explain to the tool that the code is just exactly the same, or it's similar code and you can extract it, or here's the semantical closed piece of code, just because you might do things in a very different way. And so you have to take all this language specific into account, or you have to follow some specific style to be able for the tool to help you with this kind of enforcement. And then we came to the next group of core guidelines checks when we ask ourselves, should we really do some enforcements here? So because they are possible, but maybe that's not the right thing we want to do. As an example, so I took the F4, 5, and 6 rules here. So, and they all about like declaring the things with some specifier like const expr or inline or no except. In general, it's a good check, like it's a good thing to make the thing which is actually const expr, define it as declare it as a const expr. So it's good. But the thing is that and they say it in the guideline that over the last 40 years or so, we've been promised that the compilers can inline better than humans without any hints from humans. And we're still waiting for that. So that's why we have this guideline for doing the things on our own. So is that really toolable? If we don't believe the compiler can do that, why do we believe that the code analyzer can do that? And the next point is that these things like const expr, inline, and no except are actually part of the interface. And changing the part of the interface with some automated fixes is probably not conceptually right. So if that's an explicit action called by the developer, then yes, but like doing some automation here might actually do more harm. And like, for example, you might convert the function to the declare it as const expr, but later you might come and decide that, hey, I want to add some logging here to the function. So, and I have to, revert it back, but it might be not easy because again, that's a part of the interface and we prefer not to change the part of the interface quite often. Some things are still possible here. So there are some code analysis checks flagged in some cases, like no except checks for like swap and move. And there's these guidelines rules in section C, like make move operations, no except, make swap operations, no except. And we do implement them in our tools because we think that's a valuable check and that's a reasonable check to have. But in other cases, we have to be very careful. So we can't just blindly, convert the code, or we can blindly put all these red squiggles under the code because probably that would be just too much noise. And we want to avoid the noise in code analysis as much as possible. Okay, so if we talk about the tools supporting the code guidelines, because as I said, it's essential to have the tools. If there are no tools, the code guidelines probably won't work at all for us. But there are tools already. So there's this GSL library maintained by Microsoft. This is the namespace GSL functions and types that are suggested for use by the C++ core guidelines. And there's these C++ core guidelines checkers implemented in Visual Studio. I don't know how many of them they have for now. So what's the coverage for them right now? In Clank Tidy, it's, I guess, something about 40 or a little bit more checks implemented in the CPP core guidelines section. There is a Sonar family of tools, and I guess that's about 80 or something like that rules in these, like Sonar Lean, for example, the code analyzer you can use in your IDE, so just run it separately on your code, or use the Sonar Cube on the CI side. And yeah, in our tools, we mostly utilize the Clank Tidy power, and some checks are implemented on our own. So yeah, you can find the tool which does support the core guidelines and which will enforce the core guidelines on you these days. Since we mentioned the Clank Tidy, let's talk about the Clank Tidy. So with the Clank Tidy, so there are lots of checks, and the community actually actively contributes to it, which is great. So like when you see the tool of that kind where the community contributes a lot, that's the best thing we can have in the community. And the great thing is that you can implement your set of checks specific to your company, your project, or maybe your specific DSL you are using on top of C++. But there are that many checks. Do we really need all of them? Definitely no. And even some checks which are like in the trunk of the Clank Tidy, you probably don't need them all. Like the Google the Google is contributing lots of checks to the Clank Tidy, but some of them are very specific to their code base, and there are some other examples like that. There are some very good groups like Modernize and C++ Core Guidelines groups. They are probably good to have them by default if you're, like, for example, converting to the newest standards. And if you talk about the Clank Tidy, there are actually several policies how we use the Clank Tidy usually in our code base. In general, I call them asterisks and minus asterisks. So the asterisk model is when you that's just how the config line for the Clank Tidy looks like. So the asterisk means you just enable everything and then disable some groups. And on the contrary, there's another approach when you use the minus asterisk, when you disable all the checks and then enable some particular groups. And there are pros and cons about any of this group. And the main point here is probably that if you get a new check, there could be two situations which will be bothering you. In the first approach, you might get the checks you don't want, and there will be quite noisy analysis for you. And that's what we actually met several times in C-Line when we're using the default profiler in C-Line for the Clank Tidy, which you can always change, but still that's the default. We're using this asterisk model. So if there is a new check appeared in the Clank Tidy, it might be on by default for you if you're relying on like C-Line's default config. And we had several complaints in the past when some checks like this one, LVM libc namespace related check was introduced, and the code base for many users was just covered with these red squiggles with this check, and they actually didn't want to see that. But if you have the minus asterisk model in use, then probably you're missing some checks, and you probably will never learn about it if you don't, I don't know, read through the release notes or somehow check the new additions to the Clank Tidy tooling. So yeah, this kind of models, they are tricky. And another aspect you have to remember when you're using the Clank Tidy, so if you're using it separately out of these like IDEs or something, it could be quite performance greedy because it will run on the file you're running it on, building the full AST from scratch every time you run the analysis. So how it's usually done, like for example, how we do that in C-Line, say, since we are relying on the Clang-based language engine, we don't run the Clank Tidy from scratch every time you need the analysis for the current file. We just reuse the AST, which is already built by the Clang, and so it's much faster. I would say it's much faster. So you have to take this performance aspect into account. So just running the pure Clank Tidy from scratch could take some time. Apart from the Clank Tidy, there are actually lots of specific analysis in our areas. So, and this analysis is mostly about some specific of the code you are like writing. For example, if you have the Qt code and you have these signals and connections in the Qt code. So there is, for example, this Clazy analyzer, which knows about this specific, and it can provide you some additional checks with this knowledge of this like let's call them extensions. Also, there is like, for example, in Unreal Engine world, in the game dev, there is UHT Unreal Header tool, which is also a code analyzer used by the Unreal Engine developers. It's built into the compiler, and you can also run it separately, and it provides you additional knowledge about these language extensions, which are these reflection mechanism built into the Unreal Engine on top of the macros. And also there are like the specific MISRA and AUTOSAR that's mostly not about the specific semantic of the code, but mostly about the security issues, which they do care a lot in the embedded programming, and which is a part of the certification process, as I already mentioned, especially for the automotive industry. So there are several specific analyses here. And I want to mention MISRA here specifically because during the recent years, I see some very interesting trend when the people are demanding the in-editor code analysis for MISRA. Why? What's the reason? So actually, the MISRA as part of the certification process, it's a must-have. So, and you have to pass the MISRA certification sometime after you actually finalize the code. And fixing the issue at this stage might take the time and might take the effort. So it's much easier to fix them before. So if you could get some analysis beforehand, it's actually quite good to have them there. And the cost of this fixing loop is much smaller. So quite many embedded developers are now requesting the MISRA checks to run on the like code editing, code developing stages. So, and after that, like pass their certification with the whole profile. And yeah, so the good thing is that if you have this as a standalone analyzer and not on the certification stage, because the certification stage means that you just get the code, you run it through these analyzers, and you have this, list of things which just went wrong. But if you just use some static analyzer, which is capable of showing you these MISRA rules violations, you probably might get some more detailed messages, or you might even get the quick fix, which will fix the problem automatically for you. And with this demand, I see many tools implementing the MISRA checks. I know that PVS Studio has the MISRA checks, and we build MISRA checks in C-Line. I know that SonarLean has MISRA checks. Maybe this develop as well. Peter probably knows better. So yeah, there are MISRA checks now built into the IDEs, into the code analysis checks, because there is a demand. And this is very interesting to see this demand coming from the developers, actually, those who are maintaining the embedded systems. So they want to shorten the loop. So they want to get the checks on their code while they're developing it, and then pass their certification on the same set of rules separately. So interesting thing here to mention. So I talked many times about different guidelines and tools, and sometimes you can see that there are the same checks, for example, in several code analyzers and in several approaches, like the dangling pointer approach. And actually, yeah, we do care about the same things. And I have an example here, like in C++ core guidelines, there are several rules about the VARX argument and about defining a C-style variadic function. A very similar checks are there in MISRA. And also a very similar check is there in CERT, which is C++ coding standard certification by the CERT Coordination Center. So there is also a very similar check there. So they are all about the same. So actually this is the same rule. So you can enforce it by the tool which has support for it. So yeah, so we have many guidelines, but they are obviously talking about the same rules to apply to your code base. Okay, so this is the list of tools we already discussed. Now, the last thing I want to discuss in terms of the tooling here is the style and naming thing. So I don't want to spend much time on that, but it's still very important. Why? First of all, because the people do treat the Clang format now seriously. And that's first of all for the readability, for the better maintainability of the code. And the Clang format is kind of more or less a standard for C++ nowadays. So you can often find some Clang format config files committed along with the code base to the GitHub, to the Git repository. So the people often commit this Clang format config along with their code base so that the others who will be contributing to the code could use the same, like at least indentation style. The interesting aspect is that they are often breaking the compatibility. So a very typical case is that when they have the variable, the setting with the true false values, and then they change it to the enum values. So you have the different values for the setting. So your config might become incompatible with the updated version of the Clang format. And also an interesting thing is that the Clang format, being a part of the Clang family, it's not using the full-featured Clang parser. I guess mostly for the performance goals, because like the formatter, the indentation tool couldn't take long. So they're using some fuzzy parser. And there's a very interesting thing here. So the community actually got used to this fuzzy parser. And when it gets something in a wrong way, they require the other tools get it in the same way, even if they are using the more accurate C++ parser. So that's just a funny story which I observed in how the people use the Clang format. Another thing is naming. Like, yeah, we know from Kate Gregory that naming is hard, but it's required for better readability and maintainability of the code so that you don't have to explain everything in your code to everyone. And it's somehow self-documented piece of code. But with the naming, so yeah, there are different schemes for the naming. So, and you can get the scheme from their names, usually like the camel case, the Pascal case, or this, which I like a lot, which is the screaming snake case used for some entities. The thing is that if we take the naming, it's not just to highlight that the naming is wrong. What you need when you run the naming analysis, you actually need and there are like these specific styles you want to confirm, for example, like the Google style or the LVM style or the Unreal Engine style. And to confirm with these things, you actually need the refactoring. So you need the rename refactoring because you need to fix the issue. And to fix the naming issue means you need to rename the variable or a function or whatever entity you are using. And if you do that manually, you'll probably run into troubles. So you need the context-aware name refactoring, so the proper name refactoring, not just the text search, to rename the variable or a function or whatever properly. So when we talk about the naming, it always bring us to the effort that we need a proper refactoring to fix this naming. And since I mentioned at the very beginning of my talk, I mentioned these style wars. In C++, you can do things in many ways. And the typical example of this kind of the style war is probably the east const vs the west const. And I'm not gonna say which is right and which is wrong. So I'm gonna say that you probably want to have one or another on your code base and you want to enforce it. And there are other examples like how and when to use the outer, if I would like to use the trailing or the regular return types in function declarations, because you probably know that the trailing is the only way for lambdas. So for consistency, many people would require the trailing return time to be used across their code base. So this is just the style. This is how you decide for your code base, for your team, for your project, for your company. And it's good when there is a tooling which helps you enforce this style, because actually all these ways of writing C++ code is correct in terms of the language. So, but you just need to find out the style you want to use, and you need to find the tool which is enforcing this style on you. That was exactly the point why we implemented this kind of syntax style rules in ReSharper C++ in our extension for Visual Studio. So to help people enforce this style and select what they prefer the most, is const or the west const, and enforce it on their code base with the quick fixes. Okay. So we talk about the static analysis tools, about the software quality and the developer's frustration, which they try to address. And we talked about the language, which helps with some recent proposals I've mentioned. And actually, there's lots of tooling in the ecosystem which can help you, starting from just the compiler checks. Do use them if you don't use anything else. There are also standalone analyzers and the tools bundled into the IDEs, and it's seems that many people are using the IDE's bundled tools as their main choice, main preference. And also there are like core guidelines and the tools which has support for it. And there is the Clank family tools, which is capable of many things these days. And to wrap up this talk, I would like to just throw you a very interesting idea, which I met while I was thinking about this talk about the code analysis. I met this idea of the biggest point with the code analyzers tools themselves when you work with them is the frustration coming out of the fact that you see lots of noise generated by the code analyzer on top of your code. And you don't want this noise. You want to fix the issues and you want the analyzer just, to shut up with all the things you don't need. And configuring it might take some effort. So I found this idea of gamifying the static analysis quite fun and very interesting. So gamification is cool, isn't it? Like it makes the analysis and the life much interesting, like as a quest, and it somehow motivates. So among developers, quite often, when you have some kind of this motivation with the badges or points or any other gamification aspects, it motivates you to pay attention and to step in. And also there are like other things which kind of can be applied. And I found this paper about the gamifying the static analysis written in 2018. I would recommend you reading through it if you're interested or you just want some fun stuff to read through. In the article, the authors actually states that understanding the code base and understanding the game world, the game mechanics, is very similar. So what you just miss in the code development is you missing this motivation point. So you're missing this reward. So what is there in common? What could help the code analysis if you take a look at it from the gamifying aspect? So first of all, like levels and decomposition. So don't show the whole list of issues, for example. So like build a profiler with some most required checks and pass this level first. When you have the first level achieved, it's much easier to move to the next level. As in games, the same in the code analysis. So like we can build several profilers for our code analysis, and first of all take the first one, then the second one, then the third one, and achieve the next level with everyone. And in that way we can decompose the task. So and there will be like less noise at every level of the development. Then we get some motivation, so we can create some pages or we can create some points or other rewards that we pass this level. So we have some things in a good way happening in our code now. And some there is this idea that instead of showing you the errors, instead of showing you the warnings, the analyzer might show you the call to actions, which motivates you actually, because when you see the list of problems, you're probably like disappointed about that many issues in your code. But if you see the list of call to actions, you're probably like more likely to apply them to your code, to think about them in some productive manner. So it might increase the code quality. And the fourth point from the article is that gamifying the static analysis might be helpful with the team collaborative work here. So you might work as a team together to to achieve the next level, just the same as in games, and to get to the better qualities. And all this stuff about the code analysis on CI for pull requests, for code reviews, they're actually doing exactly that. So trying to drive the collaborative and teamwork for the code analysis here. So that's about this idea. So, and I hope you like it and have some dreams about it. Not that I know the tool that can do that, but I'm just thinking like, why not? It would be very maybe nice to have to reduce the level of frustration coming of the code analyzers themselves. And that's it from me for today. So thank you very much, and I will. I'm ready to take some questions. So, and I also have this list of references I was using during the talk. So you might later want to get the presentation and to check some links I was talking here about. So and thank you very much again. And if you have some questions, let's just take a look at what you have. I don't see much questions for now, but yeah, there is a very nice comment in the chat that code analysis only stays if it's supported by tools and checked automatically. I think that's true, because like we are all kind of lazy. If nothing is enforcing the guidelines, the static analysis on us, we'll be skipping that. That's probably why the the compilers is the easiest way to enforce the checks on the developers, because if you just turn some settings in the compiler, you'll get the checks. So using the standalone tool is a much more complicated probably job here. But if it's again built in into your IDE, for example, it's much easier to enforce it on you. So especially if the whole team is just using the same ID and they can somehow share the config, for example. So yeah, it's kind of true. Okay, are there any questions or maybe comments, or maybe you disagree on something in this talk? So I will be very happy to hear that from you. And if you are like lazy enough to type, you can just raise your hand and I will allow you to talk and ask in voice. So that's also fine. The question like, why not have only one set of guidelines? Good question. Thank you. I would say like it would be perfect to have one and only set of guidelines, and just to have them implemented in one and only tool and have them supported in one and only code analyzer. But I guess that will never happen because we have a very diverse development and there are different requirements. Like MISRA requirements, for example, are much more restrictive as the regular C++ guidelines, for example, the core guidelines. And that's fine because they're talking about the security. They're talking about the like all these self-driving cars. You probably want a more restrictive security checks on them than on some other type of software. And also there are this specific semantic which might be there in the area you're working on, like in Unreal Engine, in game development in general, in finances, whatever. So these guidelines are different because the areas of development are different. The C++ core guidelines are kind of utilizing the general idea, which is here for us for C++. So what we can do with the language and what we should not do with the language and what is better to have in the language. So it's kind of one set of guidelines if you want it that way, but that's just for the general C++ programming. But if you take some specific area, then you have to have some specific set of guidelines, and that's fine. So you'll never have just one for everyone. Okay, there is this question like, how do you deal with guidelines that are not necessarily good, like Yoda conditions in the context of the rest of the tools? Yeah, there are like good guidelines and bad guidelines. It's better probably not to follow the bad guidelines. But anyway, there is always a reason behind the guideline rule, behind the check, and you have to understand it. If you understand this rule, if you understand this check and you agree with that, then just follow the guideline. That's straightforward. If you disagree with it, just ignore that. So I think that's that simple. That's why I think C++ core guidelines, they're doing, those who are contributing to the document, they are doing the amazing job. They're trying to explain the reasoning, to explain all the corner cases, and to provide the enforcements which make sense. So these guidelines are probably good enough. So until you, for example, have some very specific area where these guidelines simply don't work, but that's also fine. Yeah, thank you very much. Okay. Which tools can conveniently report missing includes? Nowadays, quite many IDEs can do that. So, like in general, to deal with the includes. So first of all, there is this, include what you use approach, and there are many tools helping you with that. And also nowadays, IDEs can help you a lot with the includes. I think all of them, because at the moment when you build the full AST, you can exactly right at this moment understand that you are missing some include, and you can suggest the include based on the libraries. For example, turned on for the project, or like the general libraries available on the machine where you're building the project. So yeah, mostly everyone who is dealing with the AST, and that's mostly IDEs or some like smart editors, they can suggest you some things about the missing includes. And quite often, like what we do in our tools, we suggest you to automatically add the include when you're, for example, completing the item which is not included into the current file. There are issues with that. So not everything is just that good. But yeah, overall, like mostly all the IDs somehow can suggest you something like that in these modern days. And the include what you use approach is very nice. And there are tools based on Clank to support this approach and to enforce it on your code base. If we consider multiple ways to do a thing, a problem, is there a different solution than setting up an unknowingly generic approach and banning everything else? I'm not sure how general the question is. So the generic approach is always not good if you have a non-generic code base. That's how I feel about it. If you have for example, if you develop the game with Unreal Engine, setting up the core guidelines will just make you more harm than good, because they have, for example, some contradictory syntax style rules. So that's mostly, if I remember correctly, about the override specifiers. So the C++ core guidelines advice and the Unreal Engine style advices, they are contradictory. So if you are dealing with the specific code base, like the Unreal Engine, setting up a generic approach and the generic analyzer, which just enforce the core guidelines rules, will be doing harm to you. So you have to set the specific analyzer which takes into account your specific code base, if that's possible. And that's why I said that with the compiler, you have the predefined set of checks, and they're quite general. So because they are designed for general purposes. And if you want some specific analysis, you want to actually find something which is more specific to your code base, which is more specific to the area you're developing this code base in. So, and you have to find this non-generic approach. And yeah, because, taking the generic approach and shaping it for your project, like cutting the things you don't need, might be tough. So it might require lots of efforts and you might not get the proper results. So it's always good to find something more specific, like, for example, use Crazy for Qt, or use like Unreal Engine Analyzer for Unreal Engine code base, and so on and so forth. So if you don't have this analyzer, yeah, you'll have to shape off some general guidelines, but you need to understand, again, the reasoning behind every check to see and to decide if the check applies nicely to your code base. So that's at least how I feel about it. Hopefully that answers the question. Not really sure. So sorry if not. Okay, so what we have here in the chat. Okay. What do you think are the next steps, future of code analysis, and what needs to happen to get there? Great question, I would say. Yeah, really, thank you. And like being a part of the vendor working for JetBrains, I think that's a good question for us. Like, first of all, let's start with the fun thing. I really feel that the idea of gamifying the code analysis is great. So it probably will help us to bring more people to the like this direct side of code analysis. But seriously speaking, I think what the people are mostly annoyed here is this frustration of too much noise happening to them. So when they have to tune the code analyzer to work with their code base. So the code analysis tools, you can see probably from this talk, they're very, very powerful. So they can catch lots of typical problems for you in C++. Like we know at the times when we can catch all these dangling pointer issues, all this null dereferencing and other stuff. But quite often there are lots of other things happening and you're just annoyed by this noise. And so the tool have to actually provide you a nice and intuitive way of configuring the profile for your code analysis. So if it provides that for you, then you're probably happy with it enough and you can tune it, and you have to You also need a way to share this profile and to apply it for your colleagues, for your teammates. That's why Clank tidy actually profiles is a good thing, because they are kind of, Clank tidy is I would say, standard tooling, yeah. So, and they have these more or less standard configs which you can share, and they would be used by your teammates. So, because like you can quite often share the profile from your ID, but it's not always like it's quite often not possible to import this profile into another ID. Maybe we can somehow resolve this, and that will help to promote the idea of code analysis further. So yeah, that's the idea, how I see it right now. You talked about IDs being used for most static checks. How would you see this integrated into CI, make GitHub Actions check for something that C-Line provides? Actually, this is possible. When we implement the code analysis, so in C-Line and IntelliJ-based IDEs, there is this inspect.sh script, which exactly runs this code analysis on the code base, and you can run it from the command line. And if you have these settings configured in C-Line, they are stored in some specific files. So if this inspect.sh script sees these files, it will be exactly running the code analysis on your project with these specific settings, and you can then reuse that on the CI. So you can run these checks on the CI. Moreover, in JetBrains right now, so we're working on the thing which is now in public preview. I guess it's called Kadana. It's somehow, the idea is similar to SonarQube. So when you can run the checks on a CI, and it integrates the tool from JetBrains. It integrates nicely with our IDEs, and integrates nicely with these checks, which you can get out of the inspect sh script or somehow. So it just automate this process. So, but you can do that manually. You can just take a script, and you can take the settings stored in the files and run this on CI. In ReSharper family of tools, there is also these ReSharper command line tools, which you can also run on CI. And yeah, so you will get the same analysis on the CI side. That's true that we're maybe not focusing on it a lot right now, but hopefully with Kadana, we'll be doing more in that direction. So bringing our checks to the CI in a more like natural and in more automated way. So, but yeah, you still can do that right now with the GitHub Actions as well. You suggested that gamification is fun and good. How do you feel about the research that shows that gamification of work tasks is counterproductive and doesn't solve the core problems? I haven't read this research, so you can share the link. I will be happy to read through it. You can probably share it in the Discord with everyone. So yeah, that gamification idea is just a like crazy fun I met while preparing to the talk, and I found it nice. So I haven't dived into it deeply just to understand all the pros and cons, and probably they are there. But I think that depends. So to me personally, like having these stages, having these levels. So, and for me, it's even not about, these rewards and prizes. For me, it's mostly about the stages when you see not all the things going wrong in your code, but some things which are just, first of all, very important and going wrong, then less important and going wrong. So yeah, this is all the things I would like to see, and the way I want to see the code analysis on my code base. So this is a part which I like about this gamification idea. Probably regarding the reward, I can't say that I'm that type of person. I'm not a person who's playing games a lot, but I just like it. I think it's fun. But maybe there are indeed some bad attitude to that, or something which prevents people from being productive. I don't know. So I haven't checked it in any real circumstances. So I don't know yet. I'm not saying that we are trying to implement it right now. That just one crazy idea I have, but we might take into account, I don't know, maybe for the next hackathon in the company. Why not to try that? Yeah, if I have time. So hopefully that answers. So we're very much close in time. So maybe just one last question I can take here, if you have any. And yeah, again, so like if you have any questions later, I'm available like in Discord and in CppNow Slack. Does your company has any plan of CLang community version? Very short question, very short answer is no. So no, we're not planning the community version. We have several free options for open source, for contributors, so for educators and for those like students who are like studying the programming. And we also have several discounted programs, but we do not plan the community version for CLang right now. Okay, so I think we're done for now. So thank you very much for joining me for this talk. It was really great talking to you here. Really appreciate that. And if you have any questions further, so just ping me in Discord, in CppNow Slack, and Twitter, so you can reach me out in many ways. And I will be happy to talk to you about the code analysis or the tools we do or anything related to C++ or in general. Thank you.